Okay, we're continuing our discussion of polar graphing and polar coordinates and finding areas of polar regions, really, by discussing how to find areas between regions. So the formula in general is that you take the integral from alpha to beta of 1/2 of r sub 2 squared minus r sub 1 squared. Basically, you're squaring the functions and finding their difference, that differential area, if you will. And that will tell you really what that area is between them. All right, so we're looking at this problem here. It says find the area shared by the circles r equal 1 and r equals 2 sine theta. So I want to point out real quick what each one of these is. So if I look here, this right here is r equals 1. What is it? It is a circle centered at the origin with a radius of 1 unit. Okay, so that's what's going on there. And then I have r equal 2 sine theta, which is this circle. And if you notice, it's also got this kind of 1 unit of area. 1 unit of radius. It's basically the same circle but shifted upward, and that's accounted for by the function that they give us here. Okay, so it is some constant that we're seeing here. And so if you see here, these of course span from 0 to 2 pi, but our concern really is the intersection. So what we're going to do is we're going to use a little bit of intuition, because we are going to use this formula partly, but we've got to use our own intuition, and that is that suppose that we have this area here that I'm going to highlight here in yellow. That is the area of that circle of radius 1. So we know that it's just pi r squared if you wanted to find the area of a circle. So if the radius is 1, then I can tell you right away that the area of that circle in yellow, pi times 1 squared, is just pi units squared. All right, so I will write out that area. Okay, but what we're going to do is we're going to find, okay, well, if we take this area and we subtract basically this area that I'm going to shade in blue here, because if you look at it, they're basically symmetric. But if we subtract that area, so the area of the total circle in yellow, which was the circle radius 1, and we subtract this kind of crescent at the top, that's going to leave us with the difference, which is this right here. Okay, and now the question becomes, how do we find the area of that crescent? Because we already have the area in yellow. We already said it was 1 unit. All right, so how do we find this blue crescent? Well, we're going to have to find the area between these two curves, and let me go ahead and point this out here. We're going to want to know what are the polar values here and here, so we can integrate from this point to this point and find that area. All right, so that's what we're going to do. And in order to do this, it's real simple. All we have to do is find the intersection. So let me write that note. First, find the intersections. And when we find the intersections, what we're doing is we are setting the two r's equal to each other. So we're going to say 1 equals 2 sine theta. So very simply put, we can divide both sides by 2, and we can say that the sine theta equal 1/2. All right, so where does that happen at? Okay, well, when you think about this on the unit circle, where is sine equal to 1/2? Well, if you're looking at the unit circle, or you take the sine inverse of this, you're going to get that theta equals pi over 6, or it also happens at 5 pi over 6. It's in the first and second quadrant. If you were to have overlaid a polar coordinate system over this, you would see that this right here would correspond, of course, to pi over 6, and then this over here on this side corresponding to 5 pi over 6. So we're going to use that as our limits of integration. So remember, we're going to subtract the yellow circle, which was an area of pi units. So let's find this area. Okay, let me see if I can fix this here. the area is going to be that pi units, all right, minus this area of from pi over 6, of course, to 5 pi over 6. And we're going to subtract this upper curve, which was r equal to sine theta, from this one, which was r equal 1. Okay, so we're going to say, okay, this is 2 sine theta squared minus 1 squared. Okay, and we cannot forget the 1/2 that sits right in the front of this. So let me go ahead and box this in with the square bracket and put d theta. All right, so let's see what this one works out to be when we kind of clean this up a little bit. All right, we're going to end up with pi minus, and we have again the integral from pi over 6 to 5 pi over 6. And we're going to end up with 4 sine squared theta minus 1. Okay, and so now that we've got this, of course, d theta, we're going to want to find an identity for this sine squared. So hopefully you remember an identity for sine squared of theta. And let me go ahead and clean this up. Sine squared theta is going to be 1 minus cosine of 2 theta divided by 2. All right, so that's what that looks like there. All right, and of course we have the 1/2, and I forgot it again. So there it is, the 1/2. Okay, so I've got that there. And now I think I'm ready to kind of clean this up just a little bit more by applying that identity right in there. So I'm going to continue and say that I have pi minus, again, the integral, pi over 6 to 5 pi over 6. And I'm going to have a 1/2 in the front. I'm going to have 4, and then times the cosine, 1 minus the cosine. 1 minus the cosine of 2 theta divided by 2. All right, and then minus 1. All right, and then d theta. All right, so continuing on, again, I carry that pi forward. Pi over 6 to 5 pi over 6. I end up with 4 over 2, which is a 2 multiplied by 1 minus cosine 2 theta. So let me just go ahead and do that distribution now. This is just going to be a 2. So distribute that. I'm going to have 2 minus 2 cosine of 2 theta minus 1. And then, of course, I have that 1/2 that sits in the front there. Okay, that looks okay. And I can combine my 1/2, my 2 and my 1 rather. And so what do I get? I have a pi minus, again, the integral, and pi over 6 to 5 pi over 6. It almost sounds like a broken record. We keep rewriting these things. We're going to have a 1/2 in the front. We're going to have 1 minus 2 cosine of 2 theta. And we're going to have d theta. All right, there we go. Okay, so what I'm going to do is I am going to now, let's see, distribute that 1/2 where appropriate, which is here and here. Let's see what it looks like now. I'm going to have pi minus, and now that I've done that, I'm actually going to break up this right here as its own integral. All right, just so that I can do the quick u substitution. All right, so I will distribute the 1/2 to the 1. So this is going to be pi over 6, and then this is going to be 5 pi over 6, and I'm going to have basically a 1/2 d theta. All right, and I'm going to, let's see, it's going to be minus a negative, so we can say that it's then going to be plus. All right, and it's of course going to have that 1/2. I'm going to leave that 1/2 on the outside, this 1/2 here. All right, just for the u substitution purpose, because I need that too, really. So I'm going to have 2 cosine of 2 theta, d theta, and I'm going to say, okay, my u is 2 theta. So my du is going to be 2 d theta, and I've already got the 2 d theta. That's why I didn't multiply by that 1/2. All right, so this will make this very nice then to integrate. So integrating now, we're going to have pi minus, and then here in a square bracket, I'm going to have a 1/2 theta. All right, that's integrated. 1/2 theta plus, I'm going to have a 1/2. Let's see here. Make sure I didn't mess up on any of the signs. Let's see, this minus, this minus actually goes applied here. So let's make this plus, and then this is a negative right there. There we go. That makes more sense. This negative got distributed here, but it had already gotten distributed to the cosine over there. Okay, so 1/2, let's see, sine of 2 theta. That's the integral for that. And then it's going to be integrated from pi over 6 to 5 pi over 6. All right, so now here's where the unit circle comes into play, and you need to know the unit circle. All right, so let's see here. We have pi, and we're going to have, let's see, plus, we have a negative 1/2 multiplied by 5 pi over 6. Okay, so that we have that there. And then we are going to add 1/2 sine of 2 times 5 pi over 6. Okay, and then we're going to subtract a negative 1/2 multiplied by a pi over 6. And then we subtract a 1/2 sine of 2 times pi over 6. And I think that should do it. We close off our brackets there. And let's kind of try to clean up this mess of pi's that we've got here. So we have a pi plus, all right, this one right here becomes a negative 5 pi over 12 is what it looks like. All right, but let's see, negative 5 pi over 12, I'll write that, negative 5 pi over 12. So that gets taken care of. 2 times 5 pi over 6, this becomes 5 pi over 3. Okay, and 5 pi over 3 is going to be, our sine of 5 pi over 3 is a negative square root of 3 over 2 from the unit circle. So we're going to have a plus a 1/2 times a negative square root of 3 over 2. And then over here, minus minus, this makes for a plus, and we end up with a pi over 12. And then sine of 2 times pi over 6, so this becomes pi over 3. All right, and the sine of pi over 3 from the unit circle is a square root of 3 over 2. So I've got that. So I've got a plus pi over 12, and I've got a minus a 1/2 times the square root of 3 over 2. All right, and I think that from here, everything else looks good. All right, so let's see what we can combine. I know I've got a pi, and I'm going to leave that for a second. The negative 5 pi over 12 and the pi over 12 can combine, giving me a negative 4 pi over 12, okay, which is a negative pi over 3. Okay, so we'll leave it as negative 4 pi over 12. This right here, though, we get negative square root of 3 over 4 plus another negative square root of 3 over 4. So let's see where we're at here. Okay, we have a pi, which we can write it as, if we want to use the denominator of 12, because that would be a common denominator for 1, 4, and 12. So we're going to multiply this by, let's see here, 12 over 12. This negative 4 pi is okay. Negative 4 pi over 12 is fine. And then we have this right over here has to get multiplied by 3 over 3 and 3 over 3. So that there is going to give me a negative 6 square root of 3 over 12. And now we have a common denominator and we can combine some like terms. So let's see what we get. 12 pi minus 4 pi is an 8 pi minus 6 square root of 3 all divided by 12. And we can reduce this by 2. So what do we get? We get, when we divide by 2, we get 4 pi minus a 3 square root of 3 all over 6. And that right there would represent the area between those two circles, which is this part that we shaded here in green. So remember, you've got to take the area of one of the circles, and we knew the area of this yellow one to be just pi because it was the radius of 1. So pi radius squared, so pi units, or unit squared. We subtracted this blue area because if you think about it, that's like subtracting this part that's left in yellow, and then you're left with whatever's left in green there. All right, so this right here would represent the area. It's 4 pi minus 3 square root of 3 all divided by 6 to represent the area. So a little bit long-winded here in the process, but as always, I hope this video was helpful. And remember, like and subscribe.